Okay, now that we've had a look at the scatter plot, I think it's time to move on to do the simple linear regression. Now, if we go up to Analyze, then down to Regression and along to Linear, we'll get this menu here. The dependent variable is the same as your outcome variable, so if we move Key Stage 3 score into that box, and the independents are the predictor variables, so we'll move Key Stage 2 into that box. Now, you can put multiple variables into this box, but we're only using the KS2 score at this point, but we'll learn more about multiple linear regression in the next module, so don't worry too much about that now. It is worth going over and having a look at these sub-menus up here, because that will provide us with more information about our regression and help us to interpret it. So if we start with statistics, a lot of this stuff is most relevant, again, for multiple regression, but it might be worth just checking the descriptives box, because that will give us the mean and standard deviation for our two variables. This section, the residuals section, is a good way of helping you to hunt out outliers. The case-wise diagnostics allows you to look for particularly large residuals. So residuals which, in this case, you can actually change it, but residuals which are 3 standard deviations away from the mean residual. This is very useful if you're worried about certain cases biasing the model. We're not going to do it in this case simply because we've got 14,000 odd students in the database, and it will give you a long list of maybe 100 or so outliers, which is difficult to interpret, particularly if you're new to linear regression. So for simplicity's sake, we won't look at this in this particular example, but it's definitely worth considering for any regression analyses you do in the future. So you click Continue just to shut that box. The next box to have a look at is plots. Now this can look quite confusing to start with because these don't look like words, but actually this is quite a useful menu to have. First of all, you can plot a histogram which will show you whether or not your residuals are normally distributed. Now the residual is the difference between the score that your model predicts an individual should get based on their Key Stage 2 score and the score that they actually got. So it's a measure of error, if you like. Now, one of the assumptions of linear regression is that residuals will be normally distributed. So we've got to use the histogram to check that assumption is made. It's important that we look out for these assumptions, because if we're wrong about any of them, if any of our assumptions are violated, then it invalidates the findings of the regression analysis. So it's important that we check the assumptions are met. Now, zpred and zresid, the two variables in this box that we're interested in. Basically, zpred is just the standardized predicted variables. That just means, by standardized, we just mean that it's been adjusted so that the mean value is 0 and the standard deviation is 1. Zresid is the standardized residual, so again the mean residual is 0 and the standard deviation of the residuals is 1. Now we'll put the zresid onto the y-axis and zpred onto the x-axis, so we'll draw a scatter plot of this. Now we're basically looking to check that there's no systematic variability in the residuals across the predicted variables. So we'd be worried if, for example, lower down the scale there was a lot of variation in residuals, and higher up the scale for predicted value there was very little variation. So we're actually looking for a fairly random scatter plot. Again, this is one of the assumptions of the simple linear regression, and it's important that we make sure that we meet these assumptions. Okay, so we're happy with this now. We'll just click Continue to shut it. Finally, it's worth looking at the save options. Now, this will actually allow you to create new variables in your data set. SPSS will do it automatically for you. It will allow you to create the residual for each participant or the predicted values for each participant. In this case, we'll just go for the standardized residuals. This will be useful because we can use those residuals to compare different groups within our sample. So we could, for example, once we have a residual for each participant, we could use that as a variable on which to compare things like gender or school type, to see if certain school types, for example, are more likely to to be let down by the model, for the model not to fit data from that group. So it's definitely worth collecting that variable. The rest of this stuff is again generally used to see if outliers or strange cases are a problem. So you can use them to identify cases which don't fit the model, but we won't worry about this now. We'll try and keep things simple for now. So if we click continue, that should be everything now, and we'll click OK to run the analysis.